Hi folks, sorry I couldn't be with you today, but what I would like to do is go over the problems on the review test that I gave you, and I will do a little bit in covering the chapters that we haven't done yet, so that there'll be no surprises for you next Wednesday for the test. Remember, we do have class on Monday, and yes, I'll be there on Monday, so it won't be a problem, and we'll do whatever we need to do to make sure that you get all the opportunities to get this stuff down that you need. So let's look at problem number 22 together. It says a bag contains 15 red and 7 green marbles. A marble is drawn or placed in the bag. Then a second marble is drawn. Are the events first marble is red and second marble is green independent events? Now, at its most basic level, to determine whether or not events are dependent or independent is a matter of whether or not if doing the first thing has any effect on the second thing. For this problem specifically, you've got a bag that has 22 marbles in it, 15 red and 7 green. And of course, if you reach inside and grab a red marble, there's a certain probability that you get a red marble. It would be 15 out of 22, and there'd be the probability that the second one would be green depends on whether or not you replace that first marble. This problem says a marble is drawn replaced in the bag, then a second marble is drawn. That's important. What that means is the probability of the second one is not affected by what happens in the first, because you start all over again when you replace it in the bag. So these are independent events. If the problem had said a marble is drawn, then a second marble is drawn, and it said nothing about replacing it, then they would be dependent, because the percentage chance that I would get a green marble is affected by the fact that there are now fewer marbles in the bag after the first draw. So again, because it says replaced in the bag, these are independent events. That's why we mark it as B, yes. To do the next problem, it would be helpful to look on page 623 of the book. It's in section 11.5, and it talks about expected values or expected numbers. So in this example, it says find the expected number of boys for a 3-child family. That is the expected value of the number of boys. Assume girls and boys are equally likely. So if you have, you want to know how many boys would you expect in a family with 3 children. So all the possibilities are written here. There's 3 girls, first 2 girls, last one boy, first girl, then boy, then girl, as you see right here, all the way down to all boys. So that's all the possible ways that you can have 3 kids. Then it wants to know how many boys would you expect to have. And so to find expected numbers, what you do is, I'm going to scroll here and move this just a little. So they say to make a table of all the possibilities. So what you do is you write down the number of boys that one could have. You could have 0, 1, 2, or 3. Then the probability of each one. So for 0 boys, that was girl, 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 there was only 1 instance of that. So there are 8 possibilities and 1 way to have no boys, 1 out of 8. But there were 3 ways to have 1 boy. You could have the boy first and then 2 girls, or a girl and then a boy and then a girl, or 2 girls and a boy. So 3 out of 8 to have 1 boy, 3 out of 8 to have 2 boys, and 1 out of 8 to have 3 boys. In other words, boy, boy, boy. So when we find expected value, what we do is we take the probability of each one times the number of instances, or number of children here in this instance. So the probability times 1/8 times 0 is just 0 here. 3/8 times 1 is 3/8. 3/8 times 2 is 6/8. And 1/8 times 3 is 3/8. So you find all those probabilities, the products, and then you add them together. So here, if you add all these together, you get 12 over 8, which reduces to 3 over 2, or 1.5. In other words, how many boys would you expect in a family of 3? Well, if you could have an average number, it would be 1.5, right? Now, of course, you can't have half a child, but the point being the expected value would be 1.5. And you could reason that out without necessarily doing all this, but this is helpful in doing the problem number 23. So problem 23 says if 3 balls are drawn at random from a bag containing 3 red balls and 4 blue balls, what is the expected number of red balls in the sample? So what we're going to do is have to find the probability of 0 red balls, 1 red ball, 2 red balls, 3 red balls. Okay. Now, the probability of each one is going to be the theoretical probability as defined as the number of favorable outcomes over the desired outcomes. So, for instance, you would have the probability. Sorry, I'm going to try to use my screen here. The probability of 0 balls is equal to the number of favorable outcomes over the total number of possible outcomes. So, how many ways can I get 0 red balls if I draw 3 out of a group of 7? So what I do there is first the red balls I'm interested in from 3. This is all for the top of the fraction. I'm choosing 3 out of 3. I'm choosing 0 divided by the total possible number of outcomes. Well, there are 7 total balls, and from those I am choosing 3. So the probability of 0 balls is 3C0 divided by 7C3. Now I find the probability of 1 ball. So from 3, I'm choosing 1 over 7C3. Now the probability of 2 balls is 3C2 over 7C3. Probability of 3 balls is 3C3 over 7C3. So you punch all those in your calculator and you get a number for each one. Then you're going to multiply whatever this number is times 0, because that's the number of outcomes, and therefore this part is just going to be 0. We're not going to worry about that one. Then we're going to multiply whatever this number is times 1. You're going to multiply whatever number this is times 2, and you're going to multiply whatever this number is times 3. Then you're going to add these all together, and when you do, you'll get 1.29. If you have any questions about that one, we can talk about them on Monday. So for number 24, we're going to do it like we did number 23 and like we did the example. But in this one, you have 4 children, and you want to know the expected number of girls in the family. So my gut feeling is probably be 2, but let's just make sure. So first of all, notice that you have 16 possibilities, starting with all females, going all the way to all males, and then you have the order 3 girls first, and then a boy, and so on. Okay, so there's all your possibilities. Now we need to consider the probability of, let's see, now we need to that. So now we need to consider the probability of 0, of 1, 2, of 3, and then of 4. And I'm sorry that this is so messy. So, well, for 0 girls, that means all boys, there's only 1 out of 16 of those. You see that, right? How about for 1? So with the probability of 1, you've got, well, 1, 2, 3, 4, 5. So there are 5 out of 16 ways to have. Let's see, I'll get rid of that. And actually, I just miscounted those because I had them out of order there. So let's try this again. There are 1, 2, 3. There's one female. Where's another? And 4. Okay, so not 5, but 4. So we're going to say 4 out of 16 here. Likewise, there are 4 out of 16 here, and so on. So what we're going to do is we'll get all the ways to get two girls, to have 3 girls, the probability of that, and then of 4 girls, which again is 1 out of 16. And then you multiply this 1 over 16 times 0. That's 0. 4 over 16, that's 1/4, times 1. 4 over 16 times 2, and so on. And then add all those up together, and it gives you 2. If you have more questions about that, please ask me on Monday. Problem 25 says, suppose you buy 1 ticket for $1 out of a lottery of 1,000 tickets, where the prize for winning 1 ticket is to be $500. What is your expected value? So, in other words, how much money would a person expect to make? The expected value if you bought 1 ticket. So the way you're going to figure this up is you are going to subtract the amount, you take the amount that you win, multiply it by the probability that you win, and from that number you subtract the amount that you would lose, if you lose, how much money you lose, times the probability that that happens. Subtract that from the first number. So what I did here was I said, first of all, if I win, so I spent $100, but I won $500. So technically I've won $499 because I have to subtract off the cost of the ticket. So $499 is my winnings. What's the probability that I'm going to win? Well, there are 1,000 tickets out there. I bought 1, so 1 out of 1,000. Therefore, when I multiply 499 times 1 over 1,000, or 0.001, I get 0.499. I have to subtract from that now my expected losses. My expected loss, well, if I don't win, I'm out $1, right? So I'm minus 1. What's the probability that I lose? Well, I bought 1 ticket. There are 1,000 tickets out there. Only one of them's a winner, so 999 are losers. So 999 out of 1,000 chance that I'll lose. So I've got -1 because I lost $1 times 0.999. That gives me minus 0.999. So I subtract from 0.499 0.999. So when I subtract it out, it's -0.5 or -50 cents. In other words, the expected value is for you to lose money, which is the way a lottery works. The vast majority of people are going to lose money. That's the expected value. If you have any questions about this one, please ask me on Monday.